Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just looking to sharpen your skills, there's something here for you. Don't forget to like the video and subscribe if you're into learning without the headaches. All right, that's enough from me. Let's get into it.
Until the 70th year of the last century, any car was equipped with a maximum of 3 sensors: fuel level, coolant temperature, and oil pressure. They were connected to magneto-electric and light indication devices on the dashboard. Their purpose was only to inform the driver about engine operation parameters and fuel quantity. At that time, the device of car sensors was very simple. But time passed, and in the 70s of the same century, car manufacturers began to reduce the content of harmful substances in the exhaust gases coming off their assembly lines. Automobile sensors necessary for this purpose no longer reported anything to the driver, but only transmitted information about the engine operation to the ECU. Their total number in each car increased significantly. The next decade was marked by the struggle for safety when using cars, and new sensors were designed for this purpose. They were designed for the operation of anti-lock brakes and the deployment of airbags during road accidents. ABS. This system is designed to prevent complete blocking of the wheels when braking. Therefore, the device necessarily contains wheel speed sensors. Their designs are different. They can be passive or active. Passive sensors are mostly inductive sensors. The actual sensor consists of a steel core and a coil with a large number of turns of thin enameled copper wire. To enable it to perform its functions, a steel-toothed ring is pressed onto the wheel drive or hub, and the sensor is fixed so that when the wheel rotates, the teeth pass near the core and induce electrical impulses in the coil. Their repetition rate will be a proportional expression of the speed of rotation of the wheel. Advantages of this type of device: simplicity, no power supply, and low cost. Their disadvantage is too small amplitude of pulses at speeds up to 7 km per hour. Active, which come in two varieties. One is based on the well-known Hall effect. Others are magnetoresistive based on the phenomenon of the same name. Magnetoresistive effect consists in changing the electrical resistance of a semiconductor when it is exposed to a magnetic field. Both types of active sensors are characterized by sufficient pulse amplitude at any speed. But their device is more complicated, and the cost is higher than passive ones. And the fact that they need power supply is not an advantage. Oil pressure sensor, OP. Most often it is electromechanical. Its device is divided into two parts by an elastic diaphragm, which under the action of oil pressure is deformed and moves the potentiometer slider. As a result, the resistance between the output terminal and the mass changes. When the oil pressure drops, the diaphragm is returned by the spring. Insufficient, emergency pressure sensor. It consists of the same diaphragm with a spring and a contact normally closed to ground. One of the contacts of the emergency oil pressure indicator light in the instrument cluster is connected to its terminal. The other contact of this bulb is energized when the ignition is turned on, so it starts to glow. After starting the engine, the diaphragm under the action of oil pressure opens the contact of the sensor terminal with the mass. The indicator lamp goes out. If the oil pressure drops below the permissible level, the spring closes the terminal to the earth and the lamp illuminates again, signaling a lack of pressure in the system. Engine cooling. A car with a carburetor engine was equipped with two temperature sensors. One of them switched on the electric radiator fan to maintain the operating temperature. The other one was read by an indication device. The cooling system of a modern car equipped with an electronic engine control unit, ECU, also has two temperature sensors. One uses the coolant temperature display device in the instrument cluster. The other temperature sensor is necessary for the operation of the ECU. Their device is not fundamentally different. Both are thermistors that have a negative temperature coefficient. That is, their resistance decreases as the temperature decreases. Intake tract sensors, mass airflow sensor, MAF. It is used to determine the volume of air entering the cylinders. This is necessary to calculate the amounts of fuel to form a balanced fuel-air mixture. The node consists of two platinum filaments, through which an electric current is passed. One of them is in the air stream entering the motor. The other, the reference one, is away from it. The currents passing through them are compared in the ECU. The difference between them determines the volume of air entering the motor. Sometimes, for greater accuracy, air temperature is taken into account. Throttle position sensor, TPMS. Outputs a signal proportional to the angle of opening of the air damper. It is essentially a variable resistor. Its fixed contacts are connected to the mass and to the reference voltage. The movable one, mechanically connected to the throttle axis, is connected to the output voltage. Exhaust system oxygen sensor. This device plays the role of feedback to maintain the correct ratio of air and fuel in the combustion chambers. Its operation is based on the principle of a galvanic cell with a solid electrolyte. The latter is ceramics based on zirconium dioxide. The electrodes of the design are platinum sputtering on both sides of the ceramic. The device starts to work after heating up to a temperature of 300 to 400 C. Heating up to such a high temperature usually takes place with hot exhaust gases or a heating element. This temperature condition is necessary for the conductivity of the ceramic electrolyte to occur. The presence of unburned fuel in the engine exhaust causes a potential difference on the sensor electrodes. Despite the fact that everyone is accustomed to call this device an oxygen sensor, it is rather a sensor of unburned fuel. Since the appearance of the output signal occurs when its surface is not in contact with oxygen, but with fuel vapors. Other sensors. Detonation sensor. Designed, as you can guess, to detect the detonation process in the engine. For its operation, piezoelectric properties of quartz are used. Deformation of a plate made of this material causes a potential difference at its ends. In response to the occurrence of detonation impulses, the ECU reduces the ignition advance angle. Crankshaft position sensor, CCPS. Forms an impulse corresponding to the VMT of the pistons of cylinders IN 4. Without the signal of this sensor, it is impossible to accurately determine the moments of fuel injection and spark formation. The time of their occurrence is measured by the amount of delay relative to the pulse of this sensor. The speed of rotation of the crankshaft is estimated by the frequency of these pulses. The device is most often a magnetoresistive or Hall sensor. In conclusion, the integration of sensors in modern automobiles has revolutionized the way we drive and interact with our vehicles. From enhancing safety features to improving fuel efficiency and enabling advanced driver assistance systems, these devices play a crucial role in the overall performance and functionality of cars today. As technology continues to evolve, we can expect even more innovative sensor applications that will further transform the automotive landscape, making our driving experiences safer and more enjoyable. Thank you for watching, and stay tuned for more insights into the future of automotive technology.